Before we start this video, a large thank you to Michael, J.O., two names I unfortunately cannot pronounce. Thank you so much for the support, guys. I really appreciate it. Sly Ninja, Mac Morris, Evo, Terrain Wax, Yan, Brian, Dempsey, Max, and Jims for their support on Patreon. I hope you guys enjoy the video. And a massive special thank you to Samuel Harbin for their immense support of the channel this month on Patreon. It is greatly appreciated, my friend, and I hope you enjoy the video. Hello guys, and today we're going to make it so we can fire our projectile. When I say fire, I mean, of course, firing it on multiplayer, because in single player here you can still see it, this shoots normally, but in multiplayer, if I were to try to do that, that would not be the case. So let's start by going over to our player network manager, and I'm going to make a comment here, it just says range projectile. And this is basically going to be the server RPC, client RPC, and function to fire this projectile. So you can call it whatever you want. You could put this on the character network manager, but honestly, you might want to handle this a bit differently for AI, because you don't need as intricate code for AI, because they're always locked on when they're firing. So the position of the arrow is very easy to calculate. But a player could be aiming, they could be free aim with just no lock on. They could be in the first person view or locked on. So I'm going to make this a player-specific server and client's RPC, as I've done with my series. Now, I'm taking a lot of this code from my project, and the only thing that differs is that I'm using third-person, and Dark Souls uses first-person aiming, but I think it should still work identically because I've modified it a little bit. But if you guys have any issues, let me know. I'm testing in the video, and it appeared fine. So I'm going to call the first function notify server of release projectile server RPC. And I'm going to have that require a client ID, a projectile ID, an X, Y, and Z position. This will be the direction of the arrow. And remember, as I just said, that direction could change wildly depending on if you're aiming, locked on, or just firing without being aimed or locked on, depending on your camera's tilt position. So there's a lot of variability here for this, which is why it needs to be a little bit more intricate than the AI's version. And last, we need the Y character rotation, because let's say if you rotate really fast as you're firing it, it's not going to update that on the network, so you want to sync the rotation you were at when you fired the arrow, so we can give the character its proper rotation when it fires. So this is a server RPC, and if we are the server, then we're going to use all this information to run a client RPC. So let's make a client RPC, and as you know, this client RPC will be sent to every single client, and we're going to check. And for every client that is not the one that tried to shoot this arrow, we're going to run this exact same logic on, so the arrow is fired for every representation of the character who shot the arrow across the client. So we're going to say notify server of release projectile client RPC, pass all that data, yada yada yada. We're going to do a check. If we are, or if the client does not equal the ID that sent this, so if client ID does not equal network manager.singleton.local client ID, then run the perform release projectile, which is just a function that will basically shoot this arrow for us. So this, now we're only going to need to pass the projectile ID, the X, Y, and Z position, and the Y character rotation. Actually, I think we need the client ID too, so we'll keep it there for now. So what do we do in here? Well, much of it is going to be very similar to our original projectile firing logic, but I'm just going to start writing it up here now. So the first thing you want to do is not animate the character, sorry. We're going to want to animate the bow. The character's animations will actually be handled from the server RPC that handles the actual animating the character that we made before, so the play target action animation. So I'm just going to make a comment here, actually instantiate the arrow. We need a transform location for that projectile instantiation location, which is, because this is Dark Souls, it's always going to be in your offhand. So the projectile instantiation location will be player.player equipment manager. I think it's called left hand. It's the weapon manager. Getting my projects mixed up again. Player weapon slot manager dot left hand slots dot transform. So the arrow is always going to appear in your offhand when you're drawing on a bow, basically. Now right below that, I'm going to make another comment here for animating the bow, as I said previously. And we're going to say, well, we don't need to check actually, because again, this is Dark Souls, so it's always going to be animated through your right hand. So we're going to say animator, bow animator, and then we're going to say bow animator equals player, and then we're going to say dot weapon slot manager, and then it's in the right hand slot. Okay, cool. So then we're going to use that to get component for in children, the animator. And I think this is pretty much identical to what we've had on the fire projectile action so far. We're going to say bow animator.set bool. What was that again? I'm just going to copy both of these and paste them. Yeah, so right here it's is holding arrow, I believe. Is drawn, sorry. And we're going to set that to false. And then we're going to make the bow play the fire animation. And then we're going to destroy the warm-up effects model, which is the arrow that you would have had notched on the character. So we'll replace character with player. And honestly, we can copy and paste some of this. Let me just go back and look at it. So yes, reset the player's holding arrow flag. Okay. Well, we only want to do that for the owner. But we can, and we don't need to play the animation because that's handled if you're the owner as well. So we don't need that bit right there because this is all handled if you're the owner on the other side. Because when we play that animation, it's going to send the server RPC to play the animation for us. So that's all good. Now, we do want to paste or copy and paste this player and AI bit, but we can delete the AI bit because it's not going to be used. As I said, the AI bit is so much more simple because it's always going to face the arrow in the direction of their target because they're not going to shoot at you unless they have a target. But with a player, they can just shoot at nothing. They can shoot locked on. They can shoot aimed. They can shoot with the camera tilted up in the air. So there's a lot more data we need to pass. So let's eradicate the AI bit. And if the player does not equal null, well, we don't need to check for a player equaling null because we're on the player network manager. So we can just delete that and copy everything inside and then paste that. Okay, now we're good to go. So what's in here that we need? Let's just see here. Gonna get rid of that comment. All right, here we go. We're initializing the arrow right here. So we're not going to check for the character inventory manager live ammo. We need a way to actually get the live ammo using the live ammo ID that we passed. And that's going to be pretty straightforward. We're going to say world item database.instance .get, and we're looking for get ranged ammo, but we don't have a function for that. So let's go make it. So let's go to the world item database real quick, and let's make a list of range ammunition as we did for our weapons. And I think we have for, yes, our equipment as well. So same thing. This is going to be identical. Copy and paste it, but make it a list for your range items. You can see now around this area of the netcode videos, a lot of this is going to be very similar. I wanted to make a projectile video because it's very different actually making the server inclined RPC to shoot it. But the logic in fetching IDs is going to be identical. We just get it from a list and use a numerical ID. That's the way I do it anyway because I think it's the easiest. So again, public ranged ammo item, get ammo item by ID. And just replace equipment with ranged ammo and reference the ammo items list instead. So it's just that simple, really. Nothing too technical about it. We've done it now this will be the third time, I believe. And we want to, again, assign all those range ammo items an ID, though. So we add them to our list of total items so they can get an ID as well. So everything other than that, though, is very much the same. You probably already have this done if you were saving range ammunition by now. So it might be done for you. Now let's go back and just say world item database.get ammo item by ID, and then we're going to reference the ID that we passed, and that'll give us the ammo. Now the arrow instantiation location, we already have that. It's going to be we want to reference to the item ID of the projectile, of course, or the live ammo model, sorry, of the projectile we get. So this position is going to be the projectile instantiation location. Again, it's looking very similar to the fire projectile logic. We're referencing our ammo differently, and we're referencing this position differently. So projectile instantiation location.transform.position, and we're not using the camera anymore. Let's set it to quaternion identity for now. We're going to set the rotation down here. So we're going to actually decide what way the arrow is facing using some of the stuff we've sent. Okay, so you can kind of keep that collision detection the same as replace character with player if you want. Now, down here, this is going to be a bit different, so let's delete this entirely. So if the player.characterNetworkManager.isAiming.value, otherwise, so if we are aiming, we're going to say liveArrow.transform.lookAt, and we're going to pass our new vector 3, and then we use the X position, Y position, and Z position that we had in the server RPC, so pretty straightforward. Otherwise, if we are not aiming, well, if we have a target, it's very simple. We're just going to put it towards the target, but if the current target does not equal null, you can see here we don't have a current target. So we need to actually store that. That needs to be a variable now. So I'm going to rename this current target, and this is where a bit of the refactoring comes in again. We always want to store the current target for a lot of network reasons. If you get deeper into making some utility or some functionality, this will come in handy. It's very useful to store a target. So we know that the AI always has a target, so we can just make that a base class function if we want. Now, otherwise down here, the live arrow is going to be on the, we need to pass some values here too. So it won't be the camera pivot because that's going to be our camera. So we need to change this as well. So we can make a network variable for the camera pivot here. So we could say camera look angle, for example, and we could always sync that, but we don't need to always sync that. Instead, we could just make a variable for it on this RPC, which is what we're going to do. So this is basically going to be the way the camera is facing rotation-wise up and down, the look angle. And this is important because if you're not aiming, if you tilt the camera up, obviously, you can shoot the arrow up in like free aim, and the arrow will kind of go in the direction your camera is facing. So let's make another float here called player look angle, and we'll add that in as well. Now you can make that, like I said, a network variable and keep track of it all the time for if you want to use it for other purposes, but we're only going to use it in this function right now, so I'm just going to make it a one-time thing. And when you shoot the arrow, you can just kind of sync that from the local player's camera look angle at the time that you shoot the arrow. All right, so down here, that's going to be mostly the same. So we have to give the player a current target. So what are we going to do there? Before we leave, actually, I'm going to come up here and I'm just going to make a range ammo item. And I'm going to call this ammo item. And I'm going to initialize that to the ammo item we got right here, just to clean up the code a little bit. And then I'm going to just reference this ranged ammo item instead of getting it again from the world item database. I'm doing this because I need to use this ammo item again, and I don't want to fetch it from the database twice. There's no point in searching it 2 times if we can get it the first time. So I'm just going to clean this up a little bit, and now I can reference this down here. So right here, I'm going to say ammo item equals ammo. There we go. So then physical damage is going to be ammo item dot physical damage. And I don't think I set up the fire damage for these because back when I was making this, I just gave one example and left you guys to do the rest. That is the biggest difference between this and the Elden Ring series, is that I'm going to do absolutely everything in the Elden Ring series. I thought more people wouldn't want that. I thought I'd be wasting my time, but from what it seems, a lot of the viewers would rather me go through everything in its totality. I know a lot of you guys, if you're this far into the series, you probably got a lot of this stuff done yourself, so I'm not too worried. Gonna save that now, and right here, let's go back to this problem. So, okay, so the current target. So we do have a current target for the AI, but we need one for the player. We need to keep track of, rather, the target for the player. So let's go into the camera handler scripts, and we have current lock on target. Let's delete that from here, and let's bring that over to the player manager. Now, the way I have this done is we could put it just right here on the player manager, and we could give the player manager their own target. But honestly, like, this is identical in form and function to the target that the AI has when they target you. And since we're sharing a class here as the character manager, that's what I have done in my project. And so I'm going to do inside of the Elden Ring series project because it just makes the most sense. The only different thing is how we acquire this target. As the player, we acquire it from a lock-on. And as the AI, we acquire it from a script via locate target, whatever. It's a state, right? So they're still the same thing. They're still just a target. So let's jump over to the character network manager here. And let's take a look at what we got in terms of our variables. So right up here, I'm going to make another header. I'm going to call this target. And basically, we want to keep track of which character has which target across the network. So I'm going to make a variable here called current target ID. And we need to reference the network object ID. I think that's a long. So let's make this as such. And basically, every time we locate a target, we want to update this variable so that we know which character has which target on the network. And this will be used also for when we shoot the arrow when they're locked on. That's a lot more simple. It'll be used if you want to do it with AI as well. It's the exact same thing. So let's make a call here. So I'm going to call this on this comment lock on target. I'm going to call this public void on target ID changed. And as it suggests, this will be called every single time that this ID on the character network is changed. This variable we just made rather. So when the target ID is changed, we're going to run this by setting up on network spawn. We're going to say character dot, and we want to say current target or target. We're going to call it. So let's go and make that now on the base class. So let's take this from the player manager and go to the base class and put that there. And then if you want to also, you can do the same thing with your AI manager. So let's just call it the same thing as the AI manager actually. So current target, and then we'll go to the base class and put that there. So then we just share that now. So the only thing that's different, as I said before, is the current target is acquired by different means. For a character, you're manually selecting it via lock-on. For the AI, it's done for them via the state code, but it's the same thing. So character.currentTarget is equal to, and then we're going to reference the network spawn manager. And we want to find the network object ID using that code, or that variable we just made, rather. So we're going to say network manager.singleton.spawn manager.spawn objects, and we pass the new target. Then we say dot get component, or dot game object, sorry, dot get component, and we pass the character manager. Now this is implying that your network behavior script is on the same game object as your character manager, and it should be if you're doing the things that I've done my way. If not, then edit the code as needed. Now go over to onNetwork spawn, and we're going to say player network manager dot. And then we're going to reference the current target ID. And then we're going to say on value change plus equals player network manager dot and on target ID changed. And there we go. That's good. So now every time this ID is changed, we're going to search for a network object with that ID and assign it as our target, providing as a character manager script. Now we have a lot of errors. Let's go fix these. Basically, we need to reference the player.currentTarget instead of current lock-on target now on all of these. And then we need to change the lock-on system, so we're updating that variable when we lock onto a target. That part is pretty simple. So for now, let's handle these errors. So instead of referencing the current target from the camera handler scripts, we're going to reference it from player.currentTarget. This is the one downside to starting Netcode so late. I mean, we didn't really have a choice because it wasn't out until we were a couple years into the series, but a lot of this is going back and readjusting things to make them network viable. The functionality is fine in its state, but we need to make it work with a network. So a lot of this will be renaming variables, as I'm sure a lot of you have probably done if you went ahead and started modifying some stuff yourself, which of course I encourage you to do. This series is here just as a guide and not as something to be followed 110%. And if you're doing that too, that's fine. But you definitely should not be afraid of going ahead and doing these things on your own. I assume a lot of you this far into the series probably do that though, because to make it this far, I think you would need some of that. Otherwise, you'd probably be lost many, many episodes ago. So let's continue going through this now. We're just going to reference the current target. And there we go, save that. I think there's only a dozen more of these to go. Okay, 9. So we're going to have to do one thing that's different. I'm just going to talk now as I change these variables. Before, we were just simply assigning the target when we found one locally. But since we need our character on other players' games to update their target to, when we assign our target locally, we have to assign that network variable that we just made to that target's network object ID. That will trigger that function we just made on when it changes, and then that will assign our target for every other client that has a representation of us in their game. A lot of this is mildly confusing, but then it starts to make sense when you do 50 or 100 server RPCs and client RPCs or use network variables a bunch of times. It just kind of clicks eventually. So if this is your first time learning Netcode, as I've said in many episodes now, this is not a great place to do it because we're kind of just changing a game that was already built, and that can be really confusing. So if you are new to Netcode, I strongly suggest you watch the Elden Ring in Unity series. My goal with this series is only to get you guys to walk away and learn something new. If you're just writing down the code and it's not kind of sinking into you, you're not understanding it, I really think you should take a step back and kind of look at some stuff, because the goal of making these videos is for you guys to kind of be self-sufficient, obviously, and tutorials are a great tool. They save you a lot of time, but it's really important that you know what's happening. Otherwise, when you run out of tutorials, you're kind of not able to continue. I can't stress that enough. I'm sorry I sound like a broken record when I say that, but I really do have your best interest in mind when I say these things. So yeah, we're going to say on handle lock on input here, we're going to say current target ID is equal to player.currentTarget.getComponent network object dot network object ID. So everywhere you see, this is under handle lock on input, by the way, under the input handler, everywhere you see player.currentTarget is equal to, right below that, just add that line of code, player.playerNetworkManager.currentTargetID is equal to, and then get the network object ID off of the object. And you're good to go. Save that, and you should be fine. So that should be working as intended. Now, right below all of this, actually, we don't need to do that. We can just keep them there as they are. How many left? 4. Okay, yeah, these are just a couple of naming errors again. So, again, just to reiterate, in case you missed that, we're setting the current target ID from the input manager when we find a lock on target. So just rewind if you missed that. It's very important. That's a very crucial step for this to work. All right. I think the last couple of these are simply naming conventions, and then we should be good to go with finishing the server RPC of firing the arrow. Looks good. Yes, okay, none left. All right, so what's next? Let's go over to the fire arrow action, and immediately I'm going to say if we're not the owner, return, because nothing in the script needs to be ran if you're not the owner. So we're going to go down through this, and right below here, you want to call that server RPC at the end of the code. So I'm just going to say character dot character network manager dot notify the network of firing a projectile, whatever we call that. I'm just noticing now, obviously, we don't have this on the character. That's my bad. We have this on the player network manager. So let's move that to this portion of this where we're using it for the player. So I'm just going to copy and paste the name. Copy this, delete it, and then open up where it says if player does not equal null. And right at the end of this is when I'm going to fire this. So I'll change character to player and character network manager to player network manager. So now we just pass our data, and we got to make a couple private variables because we need some more information. So we're going to pass the player dot local client ID or owner client ID. And then we need to pass the projectile ID. And then we got to pass the position of the arrow, which is something we don't have right now. So how are we going to get that? Well, we're going to make a private vector 3, and we're going to basically feed that vector 3 data depending on how we're firing the arrow. And then we just pass that position X, Y, and Z. Obviously, for the ammo, it's character.current or character inventory manager.current ammo item ID. Now, if we go up here, let's make that private vector. And we also need to make a float for the character's Y rotation. I explained that before, but I'll explain it again. The Y rotation is important because if you shoot an arrow and your code has it so you rotate towards the direction that you're shooting in, well, the rotation might happen late on the end of the person or on the end of your game object in another character's game. So we actually send the rotation at the time of us firing the arrow so we get that closer accuracy to the arrow's location. Okay, now we pass the projectile shooting direction X, Y, and Z. And then we pass the Y character rotation and the player look angle we're going to get from our camera, but I'll get to that momentarily because that's the up and down angle of the camera if you're firing without aiming, basically, if you're firing without being locked on. It's a very niche variable that won't get a lot of use, but you can still do it, so we have to include it. Y character rotation, I don't think I called it that. What did I call it again? Y rotation during fire. Okay. Now for the camera, like I said, this is going to be the up and down value, so we can reference that by going to our player camera. Getting my projects mixed up. It's called camera handler, I think. Yes, dot instance. And then we're going to reference our camera pivot. I think it's called transform, yes. Dot transform dot local Euler angles dot x. So the up and down of this rotation. And now we should be good to go. So let's save that, but now we need to actually make this data not be vector 3.0, and we need to assign Y rotation during fire. So up here, if we are aiming, what we want to do is quite simply, just above this here, we're going to say projectile shooting direction is equal to hit.point. That's it. Now the one below it, we actually don't have a hit point, so we can say projectile shooting direction is equal to live arrow.transform.forward. After we assign the rotation of the arrow, and that should be fine. And then right down here, we actually don't need to pass anything if it's locked on, because then we're just going to put the arrow in the direction of the lock on target. Otherwise, we're going to say projectile shooting direction is equal to camera handler instance.camera pivot transform.forward, so just the direction of the camera. And then we're going to say Y rotation during fire is equal to player or character dot transform dot local Euler angles dot y, and we save that, and now that should be working as intended. So we need to add our ranged ammo to our list here, so it actually gets an ID so it can be fetched. And we go into game here. You can see I'm going to shoot an arrow on the client here, and watch where it goes. going to shoot that into the wall right below that grid mark. Now, if I drag in the client, the arrow should be in the same place as it is for this host as is in the client. You can see, yes, it is. It is in the same place. So the angle of viewing is a bit different, but the arrow has landed in the same place. Now, the goal of this, so if you guys notice some minor discrepancies, let me know where, and I'll come back and polish them up. But I've taken most of this code from my other projects, so it does work there. But I have a third person over the shoulder aiming there. I've modified it, but I could have made a mistake. But the goal of this is to make the arrow land in the exact same position as it would have if you shot it from a local point of view without having to sync a network transform. So basically, if I shoot the arrow on one, it should be either really close or identically close to the location of where it lands on the other. Now, the only thing to think about in this situation is basically how the arrow gets stuck into the wall. That might also affect its final resting place because it could basically adjust the arrow's rotation and its final set in transform. So keep that into account too. I can go back and modify that code too if you want to, so it looks identical every time. Now, the next video is optional if you want to see a different way to do it, and I'm going to make a note here. This way is useful for things that don't require so much accuracy or smoothness, and I'm going to do it in this video, and it's my first time doing it in a project. I don't like it, but you might be able, or you can definitely put the code to use in other areas of a project. It's still cool to know. But the next video, I'm not even going to call it the next episode number. I'm going to give it a name like alternative method because it isn't what I'm going to keep in the project as a final version. And it's just something that might be cool to know. So, all right, guys, thank you very much for watching. I will see you in the next episode. I hope you have a good week.